Hello, welcome. My name is John Delk, and I'm excited to be a part of Universe 2022. Now, we have a virtual event again this year, but it's also a great opportunity for us to be able to interact with customers and partners. And I know the team has worked really hard to make this the best event ever. And so I encourage you, please take advantage of all the opportunities that you have to engage. And let's make sure you get the most out of the event this year. Now, the overall theme for Universe is solving your digital dilemma. Every industry and every organization is in a race to digitally transform, to touch their customers differently, to interact with their partners differently. And what we want to speak to in this session is the need for resilience in the ever changing and more complex world of cybersecurity. Because you see, a key part of that digital dilemma is that we need to find a way to do all this digital transformation, respond to the business demands, but at the same time, we have to do it in a way that places resiliency and cyber resiliency at the forefront. Your enterprise needs to be resilient, and in order to do that, you have to have cyber resiliency. Now, let me start by saying thank you to our title sponsor, Accenture. Without your support in this event, we wouldn't be able to do what we're doing, but it also wouldn't be possible with the rest of our sponsors and our partner ecosystem. You know, building cyber resiliency isn't possible without a broad ecosystem support and the integration of a number of different capabilities from partners. And so, just like that's true in cyber resiliency, it's also true for Universe. So, we thank all our partners for their support. Now, no doubt, year two of living in a pandemic has brought more stress, more challenges, and more disruption. Our businesses continued their journey to digitally transform, but in many cases, it wasn't as seamless as we had all hoped. New levels of cloud and hybrid deployment have brought new challenges and unexpected difficulties, particularly as it relates to how do we make all this secure. The various capabilities in our software tools have definitely continued to innovate. Our approaches have changed, but the reality is that the challenge around protecting our enterprises only get more complex as we digitally transform. So this year we saw a number of types of uh, activities happen with ransomware, with the increased threat surface area, with all of us working from home, a number of heightened concerns around protecting data, and then with the Log4j incident, the whole question of how to secure the software supply chain really came to the forefront. And so collectively, we've probably found that some of our traditional views of cybersecurity need to be updated and enhanced so that we aren't caught off guard as the sophistication on the types of threats increases, that we can also increase our level of awareness and our level of capability, particularly as it relates to securing the supply chain. The software supply chain has become one of the biggest areas that we need to modernize our approach. You know, when I started my career in software development, software teams pretty much did everything. We wrote all of our code, packaged all of it together. Any function that needed to be developed was sort of our responsibility. Today, the reality with modern software development approaches is that's changed dramatically. A lot more leverage happens as we pull functions and services and capabilities from other types of software providers. And over the last year, it became extremely apparent that this is a key risk. We cannot have a cyber resilience posture if we don't take this seriously, and it's something we need to take new approaches to solving. Let me use an analogy as a way of highlighting how you might think about the software supply chain. My analogy starts with water. Now, most of the time, we don't think about where water comes from. We just trust that the authorities in charge are making sure it's clean, usable, that they've done their job, and they're keeping us safe. If we're given a glass of water or a bottle of water, we usually just drink it and accept that it's going to be safe to drink. Well, let's replace water with software. The traditional software development approach has been to do the same thing we did with water. Just trust that the developers in charge of making these different functions and services that we're pulling in are doing it the correct way, are making sure it's usable and making sure it's safe. We assume that they've thought enough about security, and frankly, for a long time, we've just used it like we've just drunk water. But what if they aren't taking the right precautions? Just like sometimes chemicals or other additives end up in water and you have a new risk. Maybe somebody's allergic to something and all of a sudden that chemical in the water makes it unsafe. Well, the same thing has happened with our software. We've all found out the hard way that new risks can be introduced when we don't know as much about our software supply chain and don't take as much protection as we should. 2021 will go down as a year where this really came to the forefront. We had a massive increase in the number of attacks to the software supply chain, particularly to the open source software community, where many of the functions and services that we pull into our software come from. And so the other side of the increase in attacks is it emerged that we aren't prepared for all the work that it takes to patch after one of these attacks. Now, when you think about it, this sort of makes sense because we've become more interdependent on a variety of sources. Those different software providers and open source capabilities all are working at different paces with different release schedules. And so when a problem arises, all that interdependency means it takes longer to coordinate, longer to get in sync, more moving parts equals a longer time to patch. So in response to these risks, what have we seen happen in the industry? Well, governments and businesses around the world have begun to place a much higher priority on securing the software supply chain. We've had new legislations. We've had new requirements show up in procurement processes. We've had much more scrutiny by boards and chief security offices. All of this is becoming the norm as a way to manage this risk. Now, this is a natural response, but it's also one that's forcing all software providers to update how we think about securing the software supply chain. Now, before it comes across as all of this is headed in the wrong direction, the reality is we have lots of reasons to be optimistic. We're another year through this rapid move to accomplish digital transformation, and there have been some amazing success stories. I mean, you're going to hear some of them here at Universe. And we've adapted and adjusted our tools and our technology. We're solving new use cases. There's all kinds of things that have been improved as you think about our response to what's happened over the last couple of years. Even in your own company, I'm sure you've seen teammates be able to function and produce and accomplish things that you didn't even think would have been possible a couple of years ago. So we're definitely optimistic. But at the same time, we understand that in order for this digital transformation journey to continue and to be sustainable, we have to have enterprise resiliency, which at its heart requires cyber resiliency. At Micro Focus, we shifted our primary way of talking about our security line of business to cyber resiliency about 18 months ago. And we've been working hard with partners and trying to come up with the right set of use cases because we've seen a tremendous opportunity to help customers in a meaningful way because cyber resiliency is required for them to get the business value they're looking for. That's where the name CyberRes came from, and it's why we're using that name for the security line of business here at Micro Focus. Now, one example, one among many, and you'll see a number of others here at the Universe event, one example is the Galaxy Threat Intelligence platform that we recently released. Galaxy's basically designed to be able to pull in the constellation of threats and have a meaningful way to contextualize the information so that you can drive targeted decisions. Maybe that's by geo, by industry, all kinds of ways to cut through the massive amount of threat intelligence that's available, all the information that's available, and hone in on what's meaningful for you and your enterprise, the domain, the market you serve, those sorts of things. You see, a key to any sort of cyber resiliency is having actionable intelligence, and we are proud to take another step in that direction with the Galaxy platform. Now, I said over Universe, you're going to hear a number of other examples. And so I'm really excited about what you're going to hear and to get your feedback on the focus and innovation that we've tried to apply and to hear what's important to you as you think about use cases for cyber resiliency. I've only scratched the surface. For the rest of the keynote, my colleagues will expand on these concepts. We'll have a much deeper discussion on what it really looks like to secure the software supply chain, and then really tie this all together under the umbrella of delivering cyber resilience in a way that helps customers and partners improve their cybersecurity posture for the long term. So I'm excited you're here. I'm excited for Universe. And up next, I'd like to hand it over to my colleague, Dylan Thomas. Thank you.
Well, thank you, John. As we've seen, the software supply chain is a complex system. And in order to build resilience, let's spend some time exploring the supply chain and the myriad of threats facing us. The modern software development lifecycle is rife with potential attack vectors. With a combination of digital assets, identities, systems, and processes that could all be exploited if we're not vigilant. This really begins with the code that's created by development teams, which itself can contain vulnerabilities, intended or not. At this phase, both the developer workstation and the source control are potential attack targets. As the SDLC progresses, we start to recognize a collection of threats associated with the build process. The CID servers themselves must be secured, and the provenance of the code that is built upon must be ensured. This phase is also where we start to encounter many of the recent high-profile attacks around open source and third-party dependencies. We'll talk about those in greater detail next. Finally, the packaging and distribution process represents a final set of attack vectors against the generated artifacts. We've got to consider this as well. There are entire research sectors and papers devoted to each of these areas. So in this discussion today, we're going to hone in on the threat of dependencies. Now, as we examine threats to dependencies in the supply chain, we can observe two classes emerge, those originating from inside the perceived trust boundaries and those originating outside. Each group shares a common thread. External threats target the intentional injection of malicious code into dependencies. This should sound familiar to most of us, even if we're not used to this delivery mechanism of dependencies, because we see it all the time with phishing emails and other mechanisms for delivering malware. Now, one of the most insightful looks at external threats to dependencies is the backstabber's knife collection. In that paper, Ohm and his team defined an attack tree similar to the one you see here. Attackers have an initial decision as to whether they start with a net new dependency or whether they attempt to build an exploit path through established packages. And typically this is looking through the popular registries and package managed systems out there like NPM, PyPy, and Ruby Gems. I'll highlight a couple particularly interesting examples. Now, the first one of those is typo squatting. As the name implies, typo squatting involves tricking an inattentive developer or build engineer with common typos that you might have when entering the name of a component. And so instead, you pull a malicious alternative to an existing dependency as part of your build scripts. A pretty interesting one is the jellyfish incident. So in this case, one of the L's in jellyfish was replaced with an I. And this was a Python library that had been out there for quite some time. It's quite popular. Well, the malicious version would download an encoded file, which then was able to exfiltrate SSH and GPG keys. Now, this type of squatted version was available on PyPI for nearly a year before it was discovered and removed. Now, as we look at social engineering attacks, this is another interesting vector into the world of dependency threats. We see this frequently elsewhere, but in this case, it's commonly used to try to obtain maintainer privileges and responsibilities to a repository. And from there, the malicious actor can take over and publish net new versions that instead can contain malicious code. This is what happened in the popular event stream JavaScript package. A user was able to social engineer his way into maintainership and was then used that to publish a new version that included the ability to send highly targeted attacks that could steal crypto wallet credentials. Now, as we look further at some other use cases, dependencies can also be used as a delivery mechanism to compromise the build system for your software. So this is an intentional attack that affects downstream supply chain consumers. A great example of this was the CodeCov incident from this last year. In this attack, the attackers began by attacking and extracting credentials from a Docker image, which then they were able to use to gain access to CodeCov systems to publish a modified version of their bash uploader tool. The unwitting users of CodeCov then ran that bash uploader utility in their CI/CD pipelines, and thereby causing attackers to be able to export and exfiltrate confidential information. This hit many prominent users from more of a vendor scenario, actually, with folks like Twilio and HashiCorp being some publicly acknowledged as being hit by this attack. And finally, we'll talk a little about dependency confusion. Another name you'll hear is namespace confusion. This is a relatively new entrant on the scene. The attack works by publishing a dependency on a public registry like NPM that uses the same name as one from an internal or inner source library that may not be known publicly. So if the build scripts are not configured properly, they may actually go out and grab the improper malicious code from the public registry instead of pointing and pulling it from the internal registry that they were intending to. When this was after about a month or so, this being disclosed last year by an ethical hacker as a new vector, there were literally thousands, if not tens of thousands, of copy attacks that proliferated across NPM and some of these other repository ecosystems, looking to take advantage of companies that accidentally would be susceptible to this. Now, I'll shift gears and explore the other side of the coin. As the evolution of software has changed and driven how we build software, this means our definition of insiders and insider threats needs to adapt and change as well. The dependencies, the artifacts, containers, all from external providers that are now woven into the foundation of virtually every app or piece of software we build, change that threat. And by consuming those artifacts, the creators, in effect, become insiders to an organization. So, why is that important? Well, insiders who write our code introduce risk through the unintentional injection of flaws and weaknesses into dependencies, just like they do with custom code, right? People make mistakes. Unfortunately, we make lots of them. We're human. So that's how we get CVEs and open source components. The reality is open source developers are no different from those employed by your organization, the ones that are developing your custom code, except they typically don't have access to the same security tools that you use and assist with writing your own secure code from a custom standpoint. So they're at a disadvantage. Let's take a look at Log4Shell, which is a perfect example of an unintended flaw that existed in the common Log4j component since 2013, right? So the collective we, you're right, we all use Log4j everywhere. It was proliferated throughout organizations worldwide. And we all trusted the popularity and just the collective presence of the open source community would be able to provide the resilience we thought we had. Well, once that CVE went public, for any software that used Log4j, it really didn't matter whether that remote code execution or RCE was in a dependency like Log4j or whether it was in your custom code. If your app was affected, it was your neck on the line until the proverbial water was purified, as John talked about earlier. Now, fortunately, there was responsible disclosure. In this case, our insiders, aka the Apache team that maintains Log4j, were ready and they had a patch available. Now, Log4j is probably also the first time that the non-techies in our lives encountered dependencies and open source and these threat vectors. But you know what? We've been here before. Who remembers Heartbleed back in 2014? We had a latent defect in OpenSSL, which is another massively popular open source component. So OpenSSL was vulnerable due to improper input validation around buffer bounds, which meant that attackers could then use that to overrun and access confidential information elsewhere within the app. Now, this component, it was focused on TLS as opposed to logging. It was written in a different language. It also exhibited a different flaw, weakness, attack vector, right? But we think it's a step back. At a high level, are these really that different? And the answer is they're not. So what does that mean for us? What's the takeaway, right? Well, open source security, it's not somebody else's problem. We're all using open source. It's all of our problems, right? We have to take ownership of this. For starts, right, patch management, it reduces the risks that are associated with these threats that are widely known. Right? This is our CVE scanning. This is looking for known vulnerabilities in components and having good practices and hygiene, reacting quickly when new 0 days arise. But as we look to evolve, we have to become proactive. Well, being proactive is about identifying, mitigating risks before they become widely known and doing something about it. And that being proactive is how we're going to build resilience in the software supply chain and taking the learnings that we use around our custom code and treating open source and third-party code as our own code, because really are that extended ecosystem insiders is the world that we face. But the other good news is we've made significant progress over the past year as an industry. Now, we're still in the early days, but I'm very encouraged to see the massive movement in establishing standards and frameworks that are going to equip software producers, Micro Focus, CyberRes, Fortify included, but universally, right, to help build resilience into the software supply chain. Each of these standards and frameworks has some interesting insight to offer. Some of these may be compliance requirements for you. Other ones may just be offer a new way of looking at how you can frame and mature your program. So I really encourage anyone who's building with open source, which is all of us, to check out some of the work being done in these groups and learn from them and see how they can help you build a more mature process and drive adoption in your own organization. Now, these are similar to the steps that we've been taking ourselves. At CyberRes and Micro Focus overall, we've been adopting a holistic approach that incorporates software supply chain security into the evolution of our DevSecOps-based software factory model. Some of the ones that I'll highlight in particular that we've taken are kind of shown here on the slide. But one of the first ones is making sure that the agreements we have with our vendor-acquired software adheres to a standardized set of license agreements. And factoring in part of that, what's the response should a critical security incident occur? It's not just enough that you're doing security, it's how do you respond? As we look more at open source components, as you'd expect, we have a robust program around assessing the security posture of any open source that we're bringing in. And a lot of that does focus around looking at the CVEs and known vulnerabilities are out there, making good decisions, and ensuring that we're upgrading and maintaining with regularity. But as we've continued to evolve, there's more we can do. And that's really where we shifted our focus to spend more time looking at the overall intelligence around open source and the health of the software we're consuming. Some examples of that are assessing, who sponsors individual components and how popular they are in the community. What does the maintainership look like? As well as looking at how quickly those organizations have addressed prior vulnerabilities. Do they let them linger, or are they able to quickly respond and have patches like we saw on Log4j? These are critical decision points that we're using to help build the resiliency in our software supply chain, and they're steps that we see being adopted more readily throughout the industry and amongst our user base as well. Throughout the upcoming Universe sessions, you'll have the opportunity to learn more about how the CyberRes portfolio of solutions enable you to build resiliency across your software supply chain. And now I'm going to hand it over to Stan Wisman, who is our cybersecurity strategist for CyberRes.
Thanks, Dylan. I'm now going to take it up a level from software supply chain risks and address cyber resiliency in general. Um, we may be concerned about the source of our water, as John was talking about, but there's the issue of whether or not it's contaminated or polluted. But what if that water gets cut off completely? We have to assume that bad actors are actually in our environments already, and that we're going to have cyber disruptions. But we've got to become more resilient in the face of this fact. The concept of cyber resiliency is really the next generation of thinking on where we started cybersecurity nearly 4 decades ago. So, picking up the journey on the left, at the turn of the century, we were really focused on compliance. Think of Sarbanes-Oxley or PCI. We then had to focus on threat management and understand models like the Lockheed Martin kill chain and how we could use those effectively to better understand the cyber criminal ecosystem and how to kill those kind of attacks. Then we had the advent of digital transformation and modernization of applications, the use of cloud environments, and the increased attack surface that resulted. And let's face it, given the pressures of the pandemic and the digital transformations that have occurred since then, that attack surface has increased as the acceleration to the cloud has occurred. Now, cyber attacks along this timeline have continued to escalate. We had a major milestone as far as the size and significance of data breaches and attacks back in 2008, but ever since then, it's continued to go almost exponentially up. And it's fair to say that we even have like an epidemic going on with ransomware. And we have very active nation state actors. So as you look at the priorities that we have from 2022 and beyond, we have to be in better sync with the business leaders and help develop continuous operation plans and resiliency to be better prepared to withstand business interruptions. Enterprises are continually managing the act of running their business and transforming at the same time. It's a balancing act, keeping things running smoothly in the short term while at the same time transforming to take advantage of future opportunities. But all those efforts can be derailed or be meaningless if they cannot properly secure the business and its customers, as well as other critical digital assets. And the key to driving enterprise resiliency is to build in shock absorbers to sustain business operations, customer outreach, and nonstop business transformation during all times of crisis. We must engage and collaborate with business line owners to identify their priorities and to measure success. The conversation must enable a true partnership that enables ongoing alignment and delivers the best possible outcomes. This shift is one that's centered on ensuring that cybersecurity is embedded across the entire organization and focuses on what matters most to the business. We cannot continue to take an approach that applies security level across all assets. We can't do it like peanut butter anymore. The reality is, that when cyber disruptions occur, and they will happen, resilient organizations know where the specific business needs are, and they've done their homework, and they know where those processes are that they have to support and the assets behind them, and that's where they focus their attention. And cyber resiliency should be elevated up to the board level. Already 88% of the boards recognize cybersecurity as a business risk. And the level of an organization's cyber resiliency can impact the ability to continue to operate, can impact your brand, it can impact your revenue, as well as your consumer and investor confidence, as well as how you can deal with litigation costs and privacy and regulatory compliance. So resiliency focuses on key aspects of the business withstanding and recovering from cyber disruptions and the whole business of adapting. Anticipating attack means remaining vigilant and prepared. We've spent a lot of time and effort trying to prevent cyber attacks, and we certainly need to get the cyber security fundamentals right. But today we have to assume that bad actors will get through our defenses. And when we, withstand these disruptions, we need to be able to minimize the impact and ensure that teams across the organizations can respond calmly to an incident and be in sync and understand what their roles are. And then as you are, getting through that incident, be able to recover and restore environments to the minimal functional viability. And finally, we need to be able to learn from these experiences. And so we integrate those learnings back in so we can be better prepared for the next set of disruptions that we know will happen. So let's take a moment and look at the areas of focus that CyberRes has so we can better pivot throughout the rest of this week on what we can do to help you be more resilient. We're going to start out with application security. And the mass shift to remote work certainly has caused a heightened need to have resilient applications and security practices that support them. In addition to dealing with a high volume and frequency with which applications are being released these days, application security teams now also have to be able to contend with the challenges tied to people working remotely and having to potentially check in code from every part of the globe. Automation is critical for cyber resiliency, and we need to be able to leverage tools in our application security testing to be as touchless and process driven as possible. Ideally, if you need to suddenly scan 1,000 apps, you can automatically spin up the number of scanners that you need to be able to handle that capacity. And if you no longer need that many scanners, your system should be intelligent enough to be able to figure out how to automatically bring that number back down. With regards to integration, we need to be able to give development teams the security tools that they can use and that they can provision and run themselves. And ensure that those tools fit into how they work, into continuous integration and continuous delivery, into their IDEs as they enter code, into code pull requests. In other words, ensure that tests and checks provide fast and clear feedback to the developers. And resilient systems will focus on the 10 things that you need to fix in the application today, not the thousands of things that potentially need to be addressed over time. It uses intelligence to identify the issues that can affect and prevent the applications being able to go into production or be safe. And as we transition to the next area, many times applications front the data that we need to run our business. So let's go and address the data issue. And let's face it, data-driven approaches are providing all kinds of new value creation for businesses. However, organizations, I think, are starting to realize that they've become a little overwhelmed by all the data that they're collecting. The first step is really one around data governance and having a program that allows you to understand the data that you have, what's sensitive, and where it exists. Additionally, it can't be a point in time kind of assessment or snapshot. It must be ongoing that allows you to identify new sensitive data that's being added to the environment, but whether it's being on-prem or in cloud environments. And now the mere existence of data can pose a regulatory or breach risk. And so organizations can no longer just be a Hoover and keep sucking up that data, right? They need to be able to understand what data they need to really use, and then delete the data or get it out of their environment if they don't need it. And so that is a way of mitigating risk in and of itself. You're not going to be subject to a breach if you don't have the data on-prem or in your cloud environments. And that helps you with your regulatory compliance as well as reputational risks. And if you do need to keep it, then you protect it appropriately through access controls, encryption, or tokenization. Identities. So it doesn't matter whether identities are for the workforce or for customers, if they're user devices or things on-prem or in the cloud, the experience must be seamless as possible while remaining secure. As organizations move to zero trust architectures, identities become more important to a security scheme and mitigating lateral movement of bad actors. We also need to evolve from static authentication and access to adaptive access based on risk. Using contextual and behavioral information, we need to be able to evaluate the risk profile of the user or the entity during an access attempt. And that risk profile can be used to determine that level of access and ensure that you're able to control what that entity or user can do. Now, a key part of cyber resilience is the ability to anticipate attack before they happen. Threat research that puts a spotlight on the most likely attackers and how they operate can help identify gaps in defenses and gives you the time to strengthen weaknesses likely to be targeted. Anomaly detection models look for behavior that deviate from typical patterns, such as an unusual access by a user. Companies with an active defense posture use both SIEM and anomaly defense systems, and many times they're all in one to provide more comprehensive threat detection. Automating security also ties into building resilient systems. I mentioned that before in the context of application security. Automating repetitive security processes, and integrating that fully into the IT and development infrastructure helps break down barriers between data silos and security teams and helps preserve the security posture of the organization and reduce the dwell time of attackers. And it also honestly helps free up some of the analyst times from the more mundane or tactical activities to focus on more strategic and important actions. So that gives you an overview of some of the areas that we are focusing on. You can learn more about all these domains this week and how we can help your organization become more cyber resilient. Take advantage of our cyber res sessions we have here at MFU to learn more about our solutions. And we have business and technical breakout sessions. We have expert zones where you can interact with our solution experts. And we have workshops so you can have deeper dives. You can find out all this on the Universe website. We'd love for you to actually share your feedback on what you've heard today, and be sure to follow us on our security channels shown on this slide, as well as on LinkedIn, on Twitter, using the hashtag MicroFocusUniverse. Thank you for your time today. Recordings of this session will be made available later this week.